We're going to be talking today, of course, about net zero energy buildings. We want to get primarily to the discussion about Walgreens' experience with one of their newest stores. And we'll go through some background on that as well as the technology, and Jamie will cover that piece. But first I want to talk a little bit about net zero, do an intro, talk about the definition and some strategies. And then after we talk about Walgreens' experience, we'll wrap up by talking about how we approach energy analysis for these types of projects. So I just want to kind of start with the end in mind by answering maybe one of the big questions that our audience may have, and that is, should you attempt net zero on your next project? And our experience at this point suggests that yes, it's worth considering net zero as a target on any high-performance building project that you're considering. It has enough advantages and enough potential even for mainstream buildings that it's worth considering. But you do, of course, have to consider your specific situation. Consider the goals for your project. What are your energy goals versus financial goals versus user goals? You need to consider the scale of net zero that might technically be applicable, and I'll actually touch on that more in a couple slides. You need to consider your budget, of course. And a couple points on that. We've found that if you're thorough with your economics, so you consider not only first cost and utility costs, but also water costs and maintenance costs and potential first cost offsets, that a lot of the elements that help make a building net zero become more feasible. If budget is just too constrained, consider net zero ready as an option. So maybe your building isn't net zero on day one, but it's built so that it can become net zero at some point, and that's a viable goal as well. So consider some of those things for your next, in the framework of your next project as we talk through today's content. Now I want to step back a little bit and just look at how the industry is moving towards net zero energy buildings. Probably the most prominent path that's been set is the Architecture 2030 goal, where we're attempting to get to net zero buildings by 2030, and that's shown on the red line on your screen here. We also, of course, have the codes that kind of come in at the bottom end and force us to do a bare minimum towards that goal. And just recently, they, as you've probably noticed in your jurisdiction with the latest ASHRAE standard or IECC code, they're really ratcheting up their performance to try to push us towards that goal. And we see that here. But this screen also illustrates one of the advantages of attempting net zero as a target for your building project. On projects where we're not really considering net zero, we often have to think about what code is the baseline. We always need to compare our building design to that code. We talk a lot about percent savings. LEED has certain percent savings goals. If you are targeting net zero for your project, you don't have to worry about percent savings anymore. There's not even really a baseline. And if you're going to be hitting zero, you probably don't even need to worry too much about the energy code and which energy code you are shooting for. In fact, all of this kind of disappears, and we're left with one goal, and that is to achieve net zero energy on our building for the year. On the energy analysis side, that means I no longer need to worry about a baseline. I'm simply trying to hit zero over the course of the year. That simplicity has some benefits in the design process. And that leads me to really needing to define what I mean by net zero energy over the course of a year. The definition that I usually go back to was developed by NREL. They have a whole document that describes this definition, and it is a net zero energy building produces at least as much energy, renewable energy, as it uses in a year. And that definition could be viewed as slightly ambiguous in that it just says energy. You could actually be talking about site energy, which is most common in the United States. We're usually talking about just the number of kBTU per square foot per year that's used on site and produced on site. But it could also mean source energy, so that includes the losses at the power plant, and it could mean energy cost. Again, in the United States, we're usually talking about site energy. It is worth mentioning that in other parts of the world, especially in Europe, when people talk about net zero buildings, they're often talking about net zero emissions buildings. So that's kind of another way to view the definition. And that would be where you actually look at the carbon output of the different fuels you're using, and then the carbon saved in the renewable energy that you're producing, or the carbon that you're offsetting in other ways. But again, we primarily look at site energy as a metric here. Now I want to get to scale, which I brought up a couple slides ago. You additionally can look at net zero at different scales. So most commonly, we consider the scale to be the building footprint. So we're actually attempting for this building, or at least the building site, so maybe there's something in the parking lot, we're attempting to include as much renewable energy in that area as the building uses. You could start to look beyond the site, though, especially if you had like a campus and you could produce renewable energy somewhere else on a different property. And finally, you could look beyond the site and purchase renewable energy from somebody else. And in NREL's definition document, they actually lay these out as 4 different definitions of net zero at 4 different scales, and they call them A, B, C, and D. So you may hear these different definitions being discussed, and this is useful nomenclature and hierarchy for goals you might be setting on one of your projects. Again, to consider which scale is right for you, think about what type of scenario your building is in. Is it just a single building? Is it on a campus? Is it in some type of high-performance district or community that has community-wide goals or district-wide goals? Or is it even beyond that? Are we talking about a municipality or a state or something like that? And at this point, it's worth mentioning there are actually a couple rating systems, and maybe rating systems is the wrong word. There are a couple of organizations that are starting to evaluate and even certify net zero at these different scales. So at the building scale, a prominent one is the Living Building Challenge certification for net zero. Living Building Challenge is a wider umbrella certification that can be very difficult to achieve. A portion of that can be for just achieving net zero energy, and so they've developed a certification just for that piece of the Living Building Challenge. At the district level, we're starting to see districts discussing the achieving net zero for a district, and that might be a portion of a city block. It might be several city blocks. There's also 2030 districts emerging, and there's a website there if you're more interested in those districts. There is a net zero energy buildings database online now that tries to capture what buildings have achieved net zero. There's actually only 10 buildings on that database right now. That sort of shows how this is really an evolving field, and building designers, building owners are just starting to attempt net zero. In fact, about half of those buildings are either very small nature or science centers with lower loads and very specific use types. Now, that sort of stands in stark contrast to what Walgreens and others are beginning to attempt, taking more mainstream building types to net zero, which is a much more difficult challenge. Now I want to touch on economics just a minute. We don't have the ability to share a lot of cost information today, but I do want to talk qualitatively about economics. So there's really 2 sides to the coin in net zero economics. First, we have the energy demand, and then we have the energy production. On the energy demand side, this is a pretty typical curve for any building, with energy consumption on the y-axis here. As we attempt to drop energy consumption in the building, initially that's very cheap to do. In fact, initially some of the measures you implement may save you some first cost, but then as you attempt to save more and more energy, you start to reach this practical minimum of energy consumption for the building, and the costs go up substantially. On the energy supply side, so now we're talking about renewable energy to offset that demand. We initially start off, again, with a somewhat favorable cost curve. In fact, we get some economies of scale as we set up a larger and larger PV system, for example, or maybe it's a larger and larger wind turbine. There are some economies of scale to that, but we usually hit a point where we need to shift over to a different type of renewable energy plant. Maybe that's doing something with recovered methane, or maybe it's simply taking the PV panels and not just putting them on the roof, but putting them out in the parking lot, and there's some additional structure we have to do. And so this cost curve also kind of hits a limit. If we combine those two and we look at cost on the y-axis, we usually find that there's some practical minimum total cost. And this is really what the analysis that we're attempting to do on net zero projects to try to show trade-offs between renewable energy and energy efficiency. And this can actually lead to putting a lot more efficiency into the building than you normally would have because this energy production cost may grow steeper before the efficiency curve does. Now just a couple slides on strategy before we jump into the specific Walgreens experience. The New Buildings Institute did a study on the net zero buildings that net zero and aggressive high performance buildings, so those achieving like more than 50% savings, and found a few interesting things. For starters, almost all of them used an advanced HVAC system. So you're using something like ground source heat pumps or radiant heating and cooling to really drive down the HVAC energy usage. But at the same time, all these buildings have to capture as much passively as they can. That includes using daylighting, natural ventilation, optimizing solar gains, and that means you really have to not only put in some complex technology, but you have to really pay attention to the fundamentals of architectural design, orient your building correctly, choose the right massing so that you can let in plenty of daylighting and natural ventilation. That usually means an east-west orientation and a nice low aspect ratio, but not always. And as you're considering massing, also consider where you're going to put your PV. And that leads me to just a discussion about a specific massing element, which is building height. NREL did a separate study where they looked at the existing building stock and said, what is the potential for typical buildings to go net zero? And found that the percentage of buildings built using typical methods that could go net zero drops significantly as we get above 2 or 3 stories. So you need to consider that when you're doing your building massing. And that's, again, due to the ability to do daylighting as buildings get bigger and the ability to put PV on a roof as the building grows taller. And finally, even after you consider all those design elements, there's a lot of work to be done after the design team goes home in a net zero energy building. This is a study that we recently did at the Energy Center where we took post-mortem on some high-performance buildings that we had done energy analysis on and went back in and looked at what else could we have done to wring just a little bit more savings out of these buildings and push them towards net zero. And we found that actually the biggest components were all elements that occur after the design team's done with their work. In that way, a lot of the design has come a long way in these types of buildings. We've captured a lot of the efficiency there, but there's operations, occupant behavior, execution and construction, and commissioning all have potentially more room for improvement. And again, that's M&V of actual buildings that we have worked on and have been deployed. And the numbers for this plot, if you're interested, are in kBTU per square foot. And that's the potential for additional improvement. So now we're going to transition over to Jamie to talk more specifically about Walgreens' experience with this type of building.
All right, thanks, Charles, and thanks, Scott. One of the things I would like to do today is kind of run through the how and why. It's one of the biggest questions we've gotten is, why is Walgreens doing this and how did you do it? And I'm hoping that the first part of the presentation will be able to explain to you and answer both of those questions and how we did it, because it was quite a challenge and it was very interesting. And we learned a lot about ourselves along the way. And as I was listening to Scott talk about some of the things, I kept nodding my head. I'm like, yep, we ran into that. Yes, we ran into that. So hopefully I'll be able to share that with you and then get into how we went about designing the building and what the final product turned out to be and what we hope to learn from it. One of the biggest challenges we have at Walgreens is we have a financial requirement that any investments made must have a 20% internal rate of return within 5 years. Well, for a project like this, that was going to be extremely tough. Some of the reasons it was going to be that way, we have refrigeration. It is one of our biggest loads in the store, and unfortunately for us, our merchandising group keeps expanding our refrigeration doors. We've gone from 12 to 16, and this project had 21 doors. So it's definitely very difficult for us to try to tackle that energy usage. We also have only 14,820 square feet of roof space. That's significant for us because one of the reasons we did this project is to be able to take this project and roll it out to future stores and potentially look at existing stores. When you have a large footprint, there's definitely big opportunity on your existing footprint. And as Scott had mentioned before, we wanted to define net zero as building produced energy only. If you remember from the NREL definition, that was A, building only. We do have some wind turbines on the site, but we believe the majority of our power is going to come from the building and the solar panels on that building. Finally, our hours of operation. This was not a 24-hour store, but we still operate 15 hours a day, 7 days a week, 365 days a year. And that's the building running at all systems running in basically full power. We don't have a lot of opportunity to dial some of the systems back, and so we tend to use a lot of energy on stores. Now, I mentioned trying to put together a business case for this. 20% IRR wasn't going to work, but that we didn't want to let that get in our way. So what we decided to do is we tried to take a different look at how we put together the business case. We focused on technology, our footprint, precedents that we had set already, and finally our brand reputation. So for technology, if you see this picture, this is the installation of Pope Benedict back in 2005. If you take a look at the picture in the lower right-hand corner, you see a flip phone, and somebody is taking a picture, probably one of the few pictures. Now, fast forward 8 years, and this is Pope Francis. You can see there's a huge change in technology, and this is significant. The reason it is significant is because when we build a store, we have basically a 4-year cycle. 3 years to build, design and build the store, and then 1 year to monitor. So for us, we need to be looking at what's going to be happening in 8 years, because we need to start testing that stuff now so that in 4 years, we're ready for the next cycle of stores to go through. And we've shown a lot of doing that before. We did our first solar project in 2008. We now have 150 with 200 more on the books. We did our first LEED project in 2009. We're now in the LEED volume program working towards our pre-certification. We did our first all-LED store, both inside and out for lighting. It's now in all new stores receive an LED lighting package. So we have a history of testing these technologies very early on. And so we brought that up when we were trying to make the case for this. We also looked at our footprint. We have 8,116 stores. It's about 120 million square feet, and that's just stores only. We're just going to focus on stores for this model. So what is the impact of 120 million square feet? About 5 years ago, we went from a 28-watt T8 fluorescent down to a 25-watt. Not a very big change. We did it on our normal relamping cycle. But that saved about $765 a store per year, and that's just using a 10-cent kilowatt-hour rate nationally. But when you have such a large footprint, you end up with quite a large amount of savings. So for us, there's a huge opportunity. If we can learn something from this project, to be able to apply it to a multiplier of 8,000, there's a lot of potential to doing that, and we've demonstrated that before. And I talked about precedents. About 3 years ago, we started an energy efficiency program, and these were our first 3 projects. The first was the lighting retrofit I had spoken about. The second was putting doors on the front of our open front coolers. And the third was putting an energy management system in. We started with these 3 projects, and we proved out the business case. In the last 4 years, these have been the results. Now, if you add these up, this is over $30 million in annual savings. So we had demonstrated in the past that, you know what, we know what we're doing. Give us the opportunity to really try this project. And the last thing we focused on to create the business case was brand reputation. I'm sure all of you have seen this. It is our newest slogan, the corner of happy and healthy. And if you ever get an email from me, the very bottom will say, every day I help people get, stay, and live well. And that is what our purpose is at Walgreens. Most people think about products and services when they think of the corner of happy and healthy, but being in the facilities division, we think about how do we minimize our environmental impact. So this project is a statement and supports our brand. Well, we were successful in getting the approval to move forward with this using all those things I just mentioned. So we first wanted to set some goals. We didn't have a specific site in mind. We looked at our normal prototype store and said, all right, how do we do this? First thing we decided is that energy produced, energy consumed had to be greater than zero. Simple definition, came directly from NREL. Second thing was that it had to operate like a normal Walgreens. It would have been very easy for us to pull out refrigeration, not put outlets on the gondolas so merchandising couldn't plug things in. There are a lot of things we could have done, but that wouldn't have been successful for us. The point of doing this project is to be able to learn from it and replicate it and apply it to that footprint. Finally, to share our learnings. Doing this, we've learned a lot and a lot that we would like to share. And part of that is we want to be seen as a leader when it comes to environmental sustainability. And so doing this project and not sharing it wouldn't really be seen as being a leader in this project. We really want to push this forward, and by wanting to push it forward, we're hoping to share everything that we've learned on this project. Once we established our goals, we had to find a project. First thing, we wanted to be close proximity to corporate office. A lot of people have said, why did you build it in Chicago? I don't know why we built it in Chicago. That is one of the worst climates to do. But I will tell you that by doing it in Chicago, we figured we could probably do it pretty much anywhere except for maybe Alaska. The other reason is that some of our high-profile green projects have been away from Chicago. And with our corporate office on the north side of Chicago, a lot of our C-level executives don't get an opportunity to see the project. And we felt it was important that not only our C-level executives see the project, but people from our corporate office can, in a short drive, visit the store. So it was very important it was close to our office. We also wanted to have a cooperative developer. That was key. We knew this was going to be a challenging project, and we needed to have a good partner. We also needed a supportive community. We chose the project that we did because of the community and what they were able to do and how much they support green building. And finally, the correct time frame. As I mentioned, we didn't have a project picked out. And because our build cycle is 3 years, we didn't want to wait the first 2 years while we went through the entitlement process to start this. So we had to find a project that was ready to go when we were ready to go. And this is the project. The picture is a little fuzzy because the building was a little fuzzy. This project is actually in Evanston, Illinois, and Evanston was a fantastic community to work with, and they still are. They helped us a lot during the process. This store was built in the early 90s and was already scheduled to be knocked down with a new store built on site. We decided on this project because it satisfied all of our requirements that I just mentioned. So the first thing we did when we decided on the project is we had to figure out, could we solve for the equation that I mentioned earlier? This is what a typical Chicago store uses, 425,000 kilowatt hours per year. You can kind of see the breakdown on the left of the different energy uses. So we try to solve for the equation. No renewable energy minus 425,000 kilowatt hours. Obviously, that doesn't work, but we knew it wasn't going to work because we haven't looked at renewable energy yet. So our first pass at renewable energy, we're going to focus on solar and wind. Those seem to be the two that would help us the most towards our goal. So the first thing we did is we went absolutely crazy when it came to renewable energy. We completely covered the roof with solar, the drive-through. We put covered parking in, and we put in 4 vertical axis wind turbines. That gave us about 325,000 kilowatt hours of projected output per year. Now, to counter the 425,000, we looked at geothermal energy. This is a picture of our store in Oak Park that about 5 years ago we had put in our first geothermal system. We knew how we expected to perform, and we figured we could come pretty close. This is just a picture of the geothermal wells going in at Oak Park. So that brought us down to 340,000 kilowatt hours per year. And you can see that the loads are starting to change a little bit. We've definitely addressed HVAC and brought that load down. Lighting becomes a bigger percentage. So when you plug those in, we're close, but not quite there. So our engineers felt that, you know what, we can probably get close. This might be the way to go. Unfortunately, we were about to change that on them. And it was going to become pretty routine and a common theme as we went through this. When we began to look further into wind, it turns out that we're having a hard time finding a small wind turbine manufacturer that wanted to partner with us or was actually going to stay in business long enough and had a technology that we felt we could rely on. So we pulled the wind out. That dropped us down to about 300,000 kilowatt hours. So the engineers responded by changing our lighting from fluorescent to LED. We had done LED several years ago. We were very familiar with the technology and felt that we definitely would be able to help reduce our energy more. So now you can see that lighting has dropped down a little bit. And when you plug in the equation, we're close but not quite there yet. Engineers again felt, well, we could probably find another 15,000 kilowatt hours and try to squeeze it out. But the architects weren't about to let that happen because we were going to change things again. As we began to look at the economics of putting in parking structures, the investment was actually rather large, a lot larger than we thought it was going to be. One of the reasons is that we have to have room on the site for removal of snow and other equipment. So we didn't want to put any columns in the parking lot, so we had to create a cantilever structure. Well, that cantilever structure, the steel involved with it, actually began to really increase the cost. And at the end of the day, the production we were going to get, we couldn't justify doing that. So we pulled them out. That dropped us down to 275,000 kilowatt hours. As you can see, there wasn't a lot of production coming from those. So we had to go back to the engineers and break the sad news to them that they're no longer going to have 300,000, you're now going to have 275. So they began to look at the building envelope. First thing they looked at, you can see in the lower right-hand corner, is they looked at putting in a revolving door. Normally we do a vestibule with 2 sliding doors, but we're able to capture about 5% energy savings just by going to a revolving door. Second thing they looked at was our wall system. They looked at the R value. Typically we're about R15. We added another layer of insulation. We went to R22. We looked at going higher, but as it turns out, it became a cost investment that really wasn't delivering much of a return for us. And it was better for us to look at taking those dollars and putting them elsewhere where we could get a bigger return. We then looked at the window system. We ended up going with a curtain wall system because of the height of the windows and also because of the efficiency it was going to provide for us. And finally, we looked at our roof. And we normally have an R20 value on the roof. We increased it to R30. And again, it was decreasing return on the investment of putting more insulation in. This is just a picture of one of the thermography images and can kind of give you a good look at the different elements that are going in. Surprisingly, you'll see right in the middle of the picture, the bright white spot. That is the revolving door, and we'll discuss what happened with our revolving door a little bit later. The last thing we looked at was, since we're going to be using LED lighting, let's go ahead and use day lighting also. So this is a great example of the clear story windows that are in the space and the light that's going to come in from them. So this brought our total energy usage down to 260,000 kilowatt hours. And when we plug the equation in, it seems to work. But if you've been following this, you know the theme. We weren't going to let it stay there. The reason is that when we talked with the solar provider, we said, hey, what angle do you need to slope those panels at to get that production? They said, oh, 7 degrees. Well, when you do 7 degrees, this is a normal looking store. That's what 7 degrees looks like on a store. And that just wasn't going to work. It looked like a ski slope in the middle of Evanston. So we brought in the solar provider, brought in our architect and said, all right, we have to solve for this. We can't go with 7 degrees. What can we go with? So they came back and said, well, we can do 3 degrees. Well, it still wasn't going to work as well as we had hoped, but we were able to live with that. The problem is that the solar provider said, look, in order for us to say that we're going to get this amount of energy, they have to face directly south. When you look at the image on your screen, straight left is due north. So the building doesn't face directly south. Well, if you rotate the roof, you end up with the roof out in the parking lot. We already discussed not wanting to put any columns in the middle of the parking lot. So the architect came up with a rather ingenious idea. And what he did is he took the roof plane, broke it into 4 elements, and then placed each of those elements back on the building and stacked them. So you saw in the picture before the clear story windows. That's where those clear story windows come from. And as you can see, that image becomes basically the footprint of our store. And it actually became the driving force on what the design of the store looked like. And that left us with 256,000 kilowatt hours. Engineers obviously had to respond to that. So they looked at our refrigeration, one of the loads that we hadn't really addressed yet. And what they decided to do was go with a heater on our cooler doors that was a little different than what we typically use. This is tied into the dew point that's inside our space. So those heaters only run when when needed. And by doing that, they're able to squeeze out a little bit more energy out of refrigeration. So, as I mentioned, 256,000 kilowatt hours, 250,000, we seem to be okay. But as you can see, there's still a little space on the bottom of the screen, so obviously we're not okay. And this time it wasn't the architect's fault. This time we had a little bit of a problem. We had gone through and worked with several different companies on our energy modeling, Energy Center of Wisconsin being one of them. And we had several different numbers on what the projected solar was going to be. So after a lot of debate, we settled on a number of 220,000 kilowatt hours. By doing that, we had to really start to get into, okay, how do we go into territory we're not familiar with? Because we're looking at potentially having to reduce our energy usage by almost 60%. And so we had to go all the way to Sweden to find an answer. And what you see in front of you is a green and cool unit. It was manufactured in France, designed in Sweden. And this is a schematic of what it looks like. Basically, what this unit does is it combines heating, cooling, and refrigeration into one unit and ties it into a ground loop system. And this unit is capable of producing and handling all the thermal loads in the space. And to eke out a little bit more efficiency, the refrigerant is carbon dioxide rather than your typical R410A. Again, helped us with efficiency, but also went back to the brand reputation of using stuff to minimize our environmental impact. The other thing that we looked at, and here you can see the clear story windows. So we were going to use them for daylighting, but because we kept reducing the amount of energy we're going to produce, our engineers had to really try to find other ways to save energy. So if you take a close look at that picture, you can see every other window has a dark spot on the bottom. The reason is that these windows will actually open to allow natural ventilation into the space. There is a weather station on the roof that will communicate with the building automation system, and when conditions are right, we'll shut down our heating and cooling system and open up these windows and just naturally ventilate the space. The other thing that we looked at was the LED lighting. You know, one of the great things about LED lighting is it's a directional source. And so with traditional fluorescent lighting, you have to rely on the fixture to direct the light where you want it to go. Well, with the LED, the fixture still plays a role, but the LED itself can really help with that. So what we did on this project, we used directional lighting. The fixtures that you see here actually use a plastic medium to redirect the light towards the face of the shelves. By doing so, we were able to reduce our lighting load by 30% while still maintaining the same foot candle levels on the face of our product. So by doing that, we got down to projected 200,000 kilowatt hours of use. You can see that HVAC and refrigeration are combined. And the biggest load left, the one that we didn't touch, was plug load. And the reason is that for us, that was going to be the biggest challenge. That is going to have to relate to behavioral change. And if you've done very much research on net zero buildings, you'll find that interesting phenomena occurs is that plug load usually ends up as the largest load. So there's still opportunity for us to go further, but on this project, we felt it was going to be too much of a challenge because there are already so many changes to try to get a very transient group of employees to change their behavior to try to reduce that load. So when you plug those final numbers in, that's what we ended up with. The equation worked, and this is what we are hoping we'll be able to produce over a course of a year and what we'll be able to consume. And this is what our total EUI was estimated to be, what we estimate to produce from renewable energy sources. So we will on this project hopefully be net positive. We're not doing any battery storage on this project for the building. All the energy is being fed back into the grid. We have a net metering situation set up. And luckily for us, I know it's not happens in all parts of the country, we'll actually be paid for the energy that we put back onto the grid when we don't use it in the building. So this is what the store looks like. It opened up on November 21st of last year. One of the lessons that we learned, I mentioned earlier in the presentation that we had to find a timeline that fit. Our executives didn't want us to do this store in Evanston because it's not a very high-profile corner. But because of all the other things I had mentioned, this made the most sense. So the caveat they put on the approval was that we had to meet the existing timeline. So we had our Eco Charrette on September 24th of 2012, and this store opened on November 21st of 2013. We started construction on April 1st of 2013 and constructed this store in the same amount of time as we would a normal store. Don't do that. It is not the best thing to do. When we went in for permit, our mechanical mezzanine had one box in the middle that said heat pump, and that was it. So it was, as I mentioned, it was a big challenge. It was fun. It was kind of interesting because we were sort of designing as we go, but we're very happy with the product as it turned out. Now, we focused a lot on energy, but we did do some other things on this project. Underneath the parking lot, we have underground stormwater chambers that are actually open bottoms, so we capture nearly all the rainwater on site and will allow it to percolate back down into the water table. This is a great shot of the building prior to putting in the curtain wall. One of the interesting things that we found out, and this occurred during our energy modeling, was that because the steel was exposed to temperatures on the outside, it was transferring it onto the inside of the building, and it actually had a pretty big effect on what our heating and cooling loads were going to need to be. So we had to do a lot of insulation of that element on the outside to prevent that transfer from occurring. You can see in your lower right corner, we have a monument sign hidden by some cars, but that monument sign is also solar powered, and that does have battery storage, so we do collect the energy during the day and use it to power the lights at night. And the landscaping is all native and adaptive plant species. We're not using any irrigation water for landscaping. We've got our fingers crossed that it actually survived. We just saw it for the first time about a week ago because it's been buried under snow all year and was planted about 2 weeks before our first snow came. So hopefully it's all still alive, but we'll find out here shortly. This is the inside of the store. One of the things that you can't see, but hopefully we were able to notice, and I don't know if our customers will, that all the finishes inside this space are low VOC. Again, being the corner of happy and healthy, we couldn't do this great project that minimized our environmental impact and then bring people into a very smelly, stinky place. So with the natural ventilation, we decided we had to go with low VOC. It was one of the more difficult things to convince our executives to do because there was no return on that investment. It's simply a brand image element, but we're able to get that across the finish line. You can also see here the lights in the space. This is just kind of a schematic example of what that light is doing. It has been working very well for us. We were extremely worried that the lighting levels wouldn't be sufficient. You can only do so many photometric plans before you have to actually install it, and it's turned out to work very, very well. One lesson that we learned is that we didn't share the numbers for the foot candle levels of the photometrics with anybody. We actually took our operations people, walked them through the space, and then adjusted the lighting up and down until they found a level that they were comfortable with. I mentioned we're doing daylight harvesting. One of the other things that we're doing is we are capping the output of our light at about 80% at night. Because people are coming from such a dark environment into the store, those lights don't need to be at 100% output. So we're able to put it at 80% output, still have everybody comfortable with the light levels, and find additional energy savings. And these are the examples of the two fixtures that we've used. The one in the front uses the plastic film that you see hanging below to redirect the light. The other one uses a lens embedded in the fixture. As I said, we've been very happy with both of them, and they're working very well. One of the issues that was raised during the design was, how do you treat this building? We instructed the architect, we wanted to reflect what this building is. And so the architect of record used a lot of glazing on the west facade, which, being an architect, I thought looked great. But the engineers nearly cut my head off when we showed them the first rendering, because obviously that's going to create some issues, not only from a heating and cooling standpoint, but how do you deal with the sunlight on a western facade? So we did it through two methods. The red line that you see is about the 14-foot point on that facade. Below that, we have motorized shades that are tied into our building automation system, and using our geographical location, they will start to lower as the sun tracks across the sky and will prevent daylight from coming in no more than about 7 feet. The reason we chose 7 feet is because at 8 feet along that glass, we have our cosmetics. So it made a lot of sense for us to stop it at 7 feet. From that point up, we used a special film on the windows that will actually take that sunlight, redirect it up into the ceiling to help maximize our daylight harvesting, as well as prevent any glare from coming into the space. And finally, one of the last things that we did, talked about wanting to share this. So not only through webinars like this, but sharing this with our customers. So this is backed by our pharmacy, and it's just an example of one of the signs. We have 15 signs throughout the space that talk about this building, what we're doing, and how it minimizes our environmental impact. We not only have them inside the building, we have them outside as well. And when you're going through our drive-through, you can actually see a sign right next to you that says look up, and you can see the solar panels right above you. And it talks about how we're producing solar energy. There's also a sign that tells you to look down, and we have on our drive-through, we have brass landscape markers that will tell you where the geothermal wells are and how it ties into what we're doing in the building. We really tried to share as much as we could on this with our customers and allow them to just walk through the space on their own so that they could learn what was going on.
A couple of questions. Let me just throw two of them out and you can decide who wants to answer those. One was kind of a general question about what's the strategy in using landscaping, window treatments, and kind of occupant behavior, and how that fits into your net zero planning or strategy. And a second question was specific to Walgreens. Are Walgreens stores franchised? If so, how does that affect net zero implementation?
Well, I'll answer the second question first. Our stores are not franchised. They're all owned by Walgreens. And so for us, it was fairly easy to do. It didn't really create any issues. The big issue that was presented on this was finding a developer who was willing to work with us on this project because it was potentially going to delay the opening, was going to be more complicated, and that was the biggest challenge, but we have a pretty good pool of developers that we're able to pull from.
Yeah, the first one was, as you're thinking about your net zero strategy or design plan, how does landscaping, window treatment, and occupant behavior get figured into that plan?
Okay, so those would be things, perhaps, I'm trying to sort of think of where this audience member is coming from. Those are perhaps things that aren't generally captured in a sort of static design model. From an energy analysis standpoint, that's where I'm coming to this and other projects from. Occupant behavior, our ability to capture that with things like plug loads or use of lights and window treatments, how they're modifying shades and so forth. It actually relies pretty heavily on a small amount of research that's been done in that area. There's a lot more research being done in it all the time, but we have to make a lot of assumptions based on a fairly small amount of information. And actually, as we get more projects like this, where we have the capability of doing M&V, where we install a significant amount of monitoring throughout the building, track it for a year or more to see how it's doing and really understand how individual components are working, our models are getting better and better. But that data has only started to come in the last few years as buildings have gotten smarter. I'm not sure really where the landscaping piece comes in to net zero. The one impact that I always think of when it comes to landscaping is trees. We usually recommend that people plant deciduous trees near the site so that we can shade the building in the summer and allow the sun in the winter. That works really well, especially in this climate, as a great natural solar shade. From an energy analysis standpoint, in net zero, though, we usually don't consider any impact from that landscaping. On a new building, usually the landscaping is too young to have any impact on energy in the first couple of years. So we want to make sure the buildings can perform when that landscaping is not there. And then any benefit that it provides is a bonus. So that's sort of, I'm just trying to guess at where that question was coming from, but those are a few ways that those things can interact with a net zero building. So now we wanted to talk just a little bit about how the Energy Center and Walgreens and the rest of the design team, in this case, attack energy analysis and understanding the energy impact of a store like this during the design process. And to start with, we like to make sure that the energy analysis scope is very comprehensive and covers everything from pre-design all the way through to the operation of the store. And you can see here on the left-hand side, we have the usual, in the middle, blue arrow, we have the usual design and construction phases, pre-design, schematic design, et cetera. And then on the right-hand side are all of the different things that the Energy Center usually tries to assist with when considering energy impacts for the store or for any building. And in this case, I can kind of simplify that by asking a specific question at each design phase. So in pre-design, we really want to ask the question, is this possible? What is the potential for energy production on the site? What is really the potential minimum for energy use? Schematic design, we want to start to understand where we should focus our money or efforts. And you saw Jamie talk a little bit about how initially the focus was on HVAC, maybe a little bit on lighting, and then we started to focus on some more detailed things later. In schematic design, you really are just trying to understand where the big impacts are. Then in detailed design, we start to refine those and really start to look at that target, at really the targets on both sides of the equation that Jamie discussed. When construction documents are complete, this really should come when we're well into modeling. We want to have most of these big questions answered, and at that point, at the time of construction documents, we really just want to gauge how confident we are that the building will achieve the goals and decide whether there's any sort of last-minute things that need to be added in. But generally, we're hoping that we've got the big questions answered by construction documents, and that's when we refine our model for submittal for LEED and code compliance, if that may be the case, and other things. So some of those we view as sort of formalities. Again, most of the heavy lifting should have already been done. But then we want to also carry this model into operation of the building and really understand how the building is performing and what we need to do to stay on track. Again, as I mentioned in that post-occupancy study that we had done, a lot of the big drivers behind a building being able to achieve net zero or any amount of high performance come after the design team is done. And we're looking at things like building operation and occupant behavior. How do we pay for this analysis? I wanted to definitely recognize the fact that the webinar today is occurring primarily because this project was a part of the ComEd and NICOR new construction programs, and a portion of the analysis that the Energy Center did was actually funded through that program. The program provides some amount of that technical assistance at its own cost. And then they paid some additional incentives to help allow Walgreens and any owner really to include some additional energy improvements in the building. You see here the sort of incentive breakdown that we're able to achieve through this program. I'll talk a little bit about each of those phases of energy analysis. But first I want to cover sort of one vertical example that goes through each one of them. And that example is going to be lighting. So initially we start with a goal of net zero for this building. And for lighting, as Jamie mentioned, the initial thought was, well, the biggest thing we can do is give this building an LED lighting package. And that makes a lot of sense. In our model, we incorporated that based on what we knew about what was possible with retail and LED lighting, and found that at about 0.8 watts a square foot, we could potentially achieve net zero. So now we're talking about sort of schematic design, maybe even pre-design, where we're using a very rough version of this model to just ballpark what the lighting designer needs to achieve for wattage throughout the store. Then the electrical engineers, lighting designers went away and did some work on the lighting design with the idea of using LEDs and trying to reduce energy where possible. But there are a lot of non-energy considerations in a design of a facility like this. I mean, at the end of the day, one of the primary goals of the facility is to support good customer service and sell product, and those things don't tie directly to energy. And the initial first cut at this came back with 1.47 watts a square foot, and this is where we were able to take the modeling results and put those down next to this 1.47 watts a square foot and say, well, we're just not going to be able to achieve that net zero goal at that level. So we went back and did some redesign and lighting, and you saw some sort of innovative fixtures that we were able to bring in and drive this down to 0.89 watts a square foot. And that is still, maybe a little off that initial schematic design target, but with some of those other improvements Jamie talked about, we were able to achieve net zero with that 0.89 watts a square foot. And at this point, we're that's where we're probably getting into the end of DDs or middle of CDs. There's still a little bit left to go in design, but we've already gone through a few iterations of the energy model. So now to step back at the beginning, looking at sort of the facility as a whole, one of the first things we want to do is benchmark the potential for energy usage. And so this chart just shows the results from the Commercial Building Energy Consumption Survey, which is a DOE database of energy consumption. And this is one of the primary tools we use on any project. One of the first things we want to do is plot a building on this plot. And that dot right there is not meaningful for Walgreens necessarily. It's just this is just an example of the type of benchmarking we do by building type. The axis, by the way, is in kBTUs per square foot per year. And then we want to think a little bit about how a given building may differ from that chart. And in the case of Walgreens, we think immediately about end-use types. So here is the average commercial building in the United States and what its end uses are. We see the main thing that jumps out at us is that refrigeration is at about 4%. And looking over to a study of supermarkets by NREL, we see a pie chart that looks very different. And this is actually fairly similar to the pie chart that Jamie showed at the end of his presentation, where refrigeration is a significant portion, maybe a third of the usage. Lighting is still pretty significant, and then we have HVAC. But that looks significantly different from the typical energy usage on the left. So we may need to use some different strategies here than we do on a typical building to achieve net zero, especially because of that refrigeration load that we have to deal with. And then finally, we benchmark the energy production. So we've been working on this energy usage side of the equation. Well, now we need to go over and benchmark energy production, and that actually turns out to be significantly easier. There was some discussion around the slope of the PV panels, but that was about as complex as the production gets in terms of energy analysis. Citing it is a whole other thing, but analyzing it is fairly straightforward. We have maps of the amount of solar production. We have similar maps of the amount of wind production for a given site, and we can get a reasonable estimate for the production potential. Then we move into a conceptual model, or actually create a model of the store. And this is actually the first model that we created. And it really doesn't look like anything that was shown in Jamie's presentation. Certainly not the final design, but not even really the early designs. But that's okay. The point of the concept model was not to necessarily look pretty. It was to show us some basic ballpark information about the store, and to be able to do that quickly. So we probably turned this around in a day or two to get some fairly detailed results, but they're ballpark estimates about what the store might need to do to meet the production cap that we had to achieve. The usage cap that we had to achieve to achieve net zero. It allowed us to explore what the impact of that large west-facing storefront was. It allowed us to set that lighting power density target, and it allowed us to think a little bit more about the special loads within the store, plug loads and so forth, not only how those behave on their own, but how they interact with HVAC. And that actually leads me to the next slide. Within this model framework, we did have a slightly more sophisticated HVAC model. And at the conceptual level, for a facility like this, what we really wanted to understand is how do the different HVAC loads potentially interact? Because we have a variety of cooling loads, not only space cooling, but also freezers and coolers. And on the heating side, we have space heating and domestic hot water. And there's potential in these systems for interaction. We can potentially shift heat from place to place and recover waste heat for use in domestic hot water or heating the building. And that's eventually what was selected was this CO2 heat pump device. It's a lot more complex than a standard heat pump, for lack of a better term, a CO2 heat pump that incorporated all of these end uses. So every one of the 5 end uses you see here was served by that system, and allowed us to do some heat recovery. So that was identified fairly early as a good strategy for a store like this that has these types of end uses. Then we move into design support during DDs or the CD phase, and here we get a much more complex HVAC model and a more complex architectural model. So here's the sort of raw version of the model in Transys, which was the software we used for the more complex components of the building. And we see here that we're modeling now not only the sort of basic structure, but we're modeling controls, we're modeling pipes and wires and flows behind that. And within this model, we're actually able to get down to minute-by-minute operation of the store and see how things are interacting with climate, with the occupants moving through the building, and with the operations of a typical Walgreens store, and really optimize the controls of not only that CO2 heat pump, but some of the lighting and other elements. And this takes us into sort of the CD phase where we're really trying to optimize controls. We understand what the building components are. Now we're really just trying to optimize them. And eventually, some of those things we optimized, wall and glass properties, the refrigeration loads and how those interact with HVAC, some of the ventilation strategies, specifically the natural ventilation that Jamie touched on. And then ground loop sizing was important. So we, as Jamie alluded to, the building is served by a ground heat exchanger that's buried underneath much of the property. And that is able to supply only so much heating and cooling. And we really were trying to minimize that by sharing these loads as much as we could in the building and reducing them. And one of the key financial savers of energy modeling was to enable us to minimize the size of that ground loop, because the ground loop is fairly expensive, and through energy analysis we're able to come away with the smallest ground loop we could and still feel comfortable with operation of the building. And finally, as I mentioned at the beginning, we want to take this model into measurement and verification. So the building has a sophisticated building automation system and a dashboard on top of that building automation system that describes all of the performance of the building in multiple levels, at a level that a customer of the store can understand, at a level that the facility managers can use to understand the building operation. And we want to be able to compare that performance with the energy model. So we now have the ability to compare the two. And Jamie was going to talk a little bit more about how that's been performing.
So you've seen a lot of information about what we've done to not only design the building, but monitor all of the complex interactions that go on inside the building. And what you see in front of you are our first 2 months of data. As I mentioned before, the store opened in November. We had a very quick time frame to build, so lesson number 2 learned, don't commission the building after it opens. Try to commission it before, but because of the timeline, we had to commission before. So our data for December is pretty jumbled because of the commissioning that was going on. But what you can see here is that we are slightly over for our total consumption, which actually is great. For those of you who might be listening that are in Chicago, you know what kind of winter we've had. For those of you who are not, the winter here has stunk. It's been the 3rd coldest since 1884. It's been one of the snowiest winters. And if you weather normalize this data, we're actually 1% below what we predicted for consumption. So we are very happy with that. Where it gets a little less happy is on the solar production. As I mentioned, it has been a very snowy winter. And we are about 33% below. What you see in front of you is our dashboard that we have to take a look at how our production is doing. And as you can see on, the light colors are high production, the dark colors are low production. So what was really interesting is that during the first couple of months, every time we got a snowstorm, the screen would just be black because the snow would be covering all of the panels. But right in the middle of the screen where you can see it says Saturday, March 15th, and there was a box there that isn't lighting up. That was our first day where we actually put more power back onto the grid than we consumed. And we came out 68 kilowatt hours ahead. It was our first net zero day. Since then, we've had 5 more days that have been net zero. So we're very excited. We're finally getting to warmer weather. But this has been a pretty exciting time for us to actually see kind of the fruition of all these efforts that we put together, and we're starting to see the results. We're about 33% behind on what we expect for solar, but we're not too concerned because January and February are our lowest production months, and the days that have been very sunny, the system has been performing better than we had modeled and expected, so we hope to make that up in the coming months, and we feel that with only 2 months of data, we're fairly confident that we are going to track towards net zero unless we get a very hot and cloudy summer.
So Charles, I'll turn over to you if we've had any questions come through.
Yeah, several questions. I'll throw a couple out related to construction of the building or demolition of the old building. Is there any estimate of what it cost comparing building a net zero new construction versus non-net zero? Is there, I don't know about specific figures, but just what kind of a big difference is there in the calculation? And another one related to not the cost, but the Walgreens building itself, the old building, when it was demolished, were there any items or materials reused or recycled? What was done with materials that were deconstructed before the new building went up?
Well, let's definitely break those up.
Okay.
I know, Jamie, from hearing you talk before, I know there's a limited amount that Walgreens is able to share on the cost of that particular building. Taking the first question.
Yeah, so there was a premium for the project. Unfortunately, I can't share what that was, but it was by no means the most expensive store. And one of the things that we learned through the modeling was the effect that LED lights could have on our space and the energy savings, and it helped drive the adoption of LEDs in our new stores moving forward. And over the next couple of years, the energy savings from that alone would definitely pay for the premium that we paid on this project. Part of the cost that went into this project was the compressed time frame, as well as the design itself. When we do a second project, it's not going to look like this building. We definitely invested quite a bit of money in the architectural design of this building, and one of the lessons learned was that isn't going to be necessary on the second building. As far as the existing building on the site, Charles, 84% of that building was recycled. None of the elements that were in that building could really be reused in the existing architecture of the new building.
Okay, thanks. A couple questions, several questions related to, did Walgreens attempt to pursue LEED certification, and if so, what level? Did that come into play at all?
Yes, one of the goals was to achieve LEED Platinum certification, and we just resubmitted our documentation, and we hope this will be the last time, and we are trying to achieve 84 credits.
All right, and some questions on the energy modeling software that was used. What energy modeling platform software was used at each step of the design? Were there any shortcomings or challenges in modeling the real behaviors of the building in the models?
Yeah, sure. So there was a lot of focus put on energy analysis in this project, which was great from our standpoint. That's what we live for. The energy modeling we did was supplemented by a little bit of analysis from the engineers. So there was a variety of pieces to that. You saw a couple of them here. There was some eQuest modeling done early in design. That was also used to a certain extent for some of the incentive calculations, because it's a fairly straightforward software. We had to use Transys for some of the real heavy lifting on the HVAC system. Some of the more advanced passive components as well benefited from the detailed components of Transys. Things like specific architectural details that Transys was able to handle, daylighting, and HVAC. We also resorted to spreadsheet calculations for some things, trying to sort of bracket what the impact of natural ventilation is. There are some these software packages and others have some capabilities around natural ventilation, but in the end, we often do our own custom calculations for some of those more difficult to model items. And then we use other tools for solar PV and wind production estimation. I actually personally wasn't involved with those two items. PV watts is a common one that we'll use early in design for PV production, but I think in this project we relied heavily on the provider of the panels as well to help estimate that in more detail later in the project. So that covers a variety of the tools used.
Follow-up question on the energy modeling, just in general. How do weather extremes affect the modeling of the building? How do you address colder temperatures or anticipated longer stretches of hot weather in the summer? How do you address those in a design and building model?
Yeah, great question. So in a typical design process, we are using a typical meteorological year. For those of you who haven't gotten into energy analysis or building performance analysis, that is a fictional weather year that's been developed by the Department of Energy for many sites throughout the United States, where they look at weather patterns over the last 20 to 40 years, depending on the file you're using, and they create sort of a typical year for you. And that's what you're looking at. And that typical year usually does include some extremes. It includes a design heating day and a design cooling day. So how bad does it typically get in the summer, and how bad does it typically get in the winter? Those don't capture necessarily the once-in-a-100-year winter that we kind of had this past winter. So to be honest, no, that probability isn't really, we don't really have the ability, not that we don't have the ability, we don't have the time to capture every potential weather outcome, and the weather that we've had over the last 3 months was never really analyzed. The one thing we did do for weather extremes was look at the ground source, the ground loop, and think about how it would perform under some weather extremes, not only over the course of a season, but over the course of many years. Again, that was maybe more important because that's a really high-cost item that the energy model can really help us to understand and optimize. And the only way to optimize it but still feel safe that the building will be able to heat and cool itself is to look at some more aggressive weather scenarios. So in the ground loop model, which was in Transys, by the way, that was one of the components we did in Transys, we looked at some of those weather extremes.
All right, some questions just about the performance of the building. For Jamie, what can you tell us or elaborate on related to what you had anticipated in terms of energy use compared to what's happening now?
Well, as Scott mentioned, you can't really predict those weather extremes, and if you try to design for those, you end up with a building that's over-designed. You're going to have capacities in your systems that might only get used, in this case, 3 times every 100 years. Because we had to commission the building after we opened, we got hit with our first sub-zero temperatures about 2 weeks afterwards, and we couldn't keep the building warm. We could only get it to about 63 degrees, and we were very concerned. There were some sleepless nights because we couldn't figure out why. But as we started to go through, we were able to determine that there were some valves that were not opened up, flowing as they should be. They were set at 1 ppm and they should have been at 5. Once we did that, we had no problems. But there was about a 4-day period where we actually had to bring in heaters just to keep our employees warm. Our customers didn't really notice because they're only in there for about 20 minutes and usually have heavy coats on, and so they don't necessarily notice that it's cold, but our employees did notice. So that was one of the issues we had. The other is that it's been kind of a blessing to have this really cold weather because it's forced all of the systems to work at maximum capacity, and we've had a couple things break, which now is great because it's still under warranty for the new construction and we're able to fix it, but had that not occurred for 5 or 6 years, it would have been an issue for us then.
All right, now a question about what you might be able to tell us, Amy, about how did federal and state tax credits for renewable energy or utility incentives and rebates play into your financial calculations and payback calculations?
They played into it a little bit. One of the challenging things at Walgreens is that any incentives and rebates are always after the business case. So we are asked to build the business case and then add in the rebates and incentives to make it look better. For this project, we took advantage of the tax credits, the federal tax credits for several of the different systems. We are able to get a rebate for some of the energy modeling that was done, and also some additional rebates. But it didn't have as big an impact as we were hoping on the financial model.
Okay. And then with regards to inside the store itself, do you display the real-time data on energy use for customers to see? And what energy management software do you use in the store, and is it proprietary?
We do display the information. From one of Scott's slides, you saw a picture of the dashboard. That's actually a 50-inch monitor that sits right next to the front cash registers for all the customers to see. We actually had to turn it off a couple weeks ago when Target had their cyber attack occur and all the customer data was lost because our IT department was worried that that might be an opportunity for people to get inside our firewall. So if you've been in the store recently, it may not have been running, and that's one of the reasons why. Could you repeat the second part of the question?
Which
Which
provider, and is it proprietary?
We worked with Train. They developed a custom energy management system for us, and no, I don't think it's proprietary.
All right, thanks. Another question here on LPD reduction. Was the LPD reduction from 1.47 to 0.89 achieved through fixtures alone or fixtures and controls? You indicate controls were used, but did the proposed use of controls contribute to that reduction during the design phase?
That 0.89 is actually the installed watts per square foot of the fixtures at maximum. Most of the time, the store uses substantially less than that due to the daylighting and other controls in the space.
Yeah, we're actually for 14% below what we had modeled for lighting usage in the space.
Okay. Several people submitted questions related to the European refrigeration system, the French refrigeration system. And when you were looking at that as the option, did you examine or consider serviceability when deciding to use that system? And are there local contractors that can service that equipment?
Yes and yes. One of the big concerns, we looked domestically to try to find somebody who could create a system like that for us, and unfortunately we weren't able to find somebody domestically, so we had to go to Europe to find the system. And it's a big concern on how are we going to manage that. The interesting part is a lot of the components of that system are actually made in Chicago. So there are contractors around that are familiar with some of the components. We also have up in that mezzanine some of the hard-to-get pieces. We ordered backup parts, and so there's a small part storage area on the mezzanine for those elements that may have a lead time to get because they're coming from a long distance.
All right. Have you collected any data or impressions about the impact on the customer experience? Are sales tracking in the way you expected?
Sales are tracking better than we expected. And to give you an impact on the customer experience, about 2 or 3 weeks after we opened the store manager called us and said, would you please come and give regular tours for our customers, because she was being stopped 4 or 5 times a day and asked questions about the project. So we now have a regularly scheduled tour time of the space for customers, and we've had 5 so far, and the average customer turnout has been about 10 people.
Kind of a follow-up question there. So on the employees in the store themselves, what has been the impact on them, on their ability to manage the store? Has it created any special challenges or opportunities?
I would say it's created opportunities for them. It's an opportunity to interact more with our customers. because the customers are curious. One of the things that we did was during the employee training day that they do for a new store, we presented on the store for about an hour and explained to them what the store was. There really isn't a big impact on what they do in their daily activities because a lot of the systems in the store are controlled by the building automation system and or monitored remotely. One of the things that we have had them do, and so far it's been going okay, is we're trying to be zero waste to landfill at this store also. And one of the things employees have to do is separate their organic waste from the regular waste stream. And that's something that they're, I wouldn't say happily doing, but they are doing it, and we are starting to compost a lot of our wet waste at the store.
Okay. Question about the solar panels. What are the solar panel maintenance requirements, and how frequently do they need to be maintained?
So for the solar system, we did a power purchase agreement, and a lot of that maintenance is going to be handled by our solar provider. And what they will do is each of these panels has its own microinverter. One of the reasons we went to the microinverter is because the panels basically cover the entire roof. And if a panel goes bad and it's part of a central inverter, you may not know that for weeks or even months. So we wanted to be sure we were able to monitor each one. And the solar provider will take a look at how the system is doing. There's a little bit of natural degradation that will occur over time. But if it appears there are panels that are not working as they should or producing as much as expected, they'll go out and take a look. And we do have a hose bib up on the upper roof, so if they need to clean them off, they will. But that's something that's going to kind of be done just on a remote monitoring basis.
All right. Question about the height of the ceilings. Why the high ceilings? Couldn't the ceilings be lower to have less volume to heat and cool?
Yes, they could. But one of the interesting things about our building is that the pharmacy actually drives the height of our roof. As I showed in the slides before, we had to rotate each roof plane so it would face directly south to maximize solar production. We could have put all of those almost adjacent to each other, but because we covered the whole roof with solar, we wanted to be able to capture some daylight so we could do daylight harvesting and reduce our energy usage. So we did put that space in. The reason it's as high as it is that inside the pharmacy we have robotics equipment that assists in filling prescriptions, and so that equipment needs a certain amount of space to move, and that space happens to be 10 foot 6 inches to the finished ceiling. When you add in another 6 inches to 12 inches for the plenum space, and then we require another foot before you hit the bottom of the roof structure, you then end up with your minimum roof height. So we had to build from there. It was going to create an issue with heating and cooling, so one of the things that we do is we limit the temperature of the air that's coming out of the ductwork, and we angle it at a 45-degree angle down so that it mixes with the air below. We have gone in and put temperature sensors in, and we found that the highest point of the roof is 37 feet, that the difference between the floor and the roof has only been about 4 degrees.
A couple more questions here. What elements are considered in net zero ready buildings versus full net zero buildings?
Most commonly, the net zero ready building means that you are going to wait to install some amount of the renewable energy. That is often one of the most expensive pieces. If you look back at those economics curves, usually at the sweet spot, the renewables curve is steeper. It also is the easiest thing to add in later and still have full functionality of the facility. So it usually means you're adding in the renewable later. And to prepare for that, you just need to make sure that you have the infrastructure to support that renewable energy. So if Walgreens, for example, had gone net zero ready instead of net zero, we would have wanted to make sure there was space for the electrical equipment, the inverters, space to run the wiring. You maybe even put in a chase so that you can easily just run that wiring right up to the roof. You want to make sure that the roof structure can support the PV. In other installations, you want to make sure there's always enough space, enough room for wires and running infrastructure. That's primarily what net zero ready means.
things too that we found that was real interesting about this project, and it sort of relates to being net zero ready and how it impacted us. We normally have 800 amp service that comes to the store. In this case, we had to go up to, I believe it was 1200 amp because of the amount of power you're going to be feeding back in. So that was one thing that even if you're building a net zero ready store, you may still want to consult with a solar provider to see if that potentially is an issue, because you would hate to have to come in later and upgrade the size of your service.
Yeah, understand your local distributed generation guidelines. If there's net metering, understand that and how that's going to look, and that might allow you to avoid switching out some of your service or your meters or other electrical components.
As far as what's next, hopefully some sun and some warm weather would be really helpful, but we're going to continue to study this building. We've got some really interesting things that we've found out that really aren't related to net zero, but because of the monitoring, that might have a very big impact from a labor standpoint on what some of our store managers have to do. So we're really starting to look into that. As far as where this is going to go in the future, it's too soon to tell, but I'm hoping that this will not be the last net zero facility that we build.